Hi, we present our Euroviz short paper, LOKI, Reusing Custom Concepts in Interactive Analytic Workflows. I'm Vidya Setlur, and this is work done with Andrew Beers at Tableau Research. Natural language interfaces for visual analysis focus on interpreting users' utterances by providing useful visualization recommendations. Systems like Evisa and Evision handle impreciseness around vague numerical concepts such as cheap and high by dynamically inferring a range based on the statistical properties of the data. Users can adjust the range and save those preferences for subsequent interaction. While the concepts and their interpretation are dynamically computed during a user session, they are simple range filters with only the bounds being modifiable by the user. There is limited support for creating custom analytical concepts on the fly. Our work explores more complex filter concepts that can be saved and reused across data sources and analytical workflows. GeoSneakPeek extends the concept of data-driven scaffolds from SneakPeek by exploring how vague definitions for places can be expressed as user-defined concrete specifications of cognitive regions. Our work, LOKI, further generalizes the notion of user-defined concepts beyond places to any attribute in a tabular dataset where complex filter expressions can be saved as named concepts in the underlying data source that can be used in natural language queries. In this work, we are interested in generalizing beyond places to support user-defined concepts for any attribute in a tabular dataset. In particular, we are interested in figuring out how we can support the dynamic creation of concepts in the flow of analysis. How do we represent these concepts as concrete descriptions that match the content of the underlying data? And how do we enable the reusability of custom concepts in other analytical workflows? To address these research goals, we present LOKI, a system that allows users to save complex and bespoke queries as reusable concepts during a natural language analytical workflow. Now let's see a demo of LOKI in action. The user starts out by typing, "What can I ask about?" LOKI responds by showing two data sources, sales opportunities, online activity. The user is interested in the first data source and types, "Give me info about sales opportunities." LOKI returns with a list of the 9 attributes in the dataset. The user then proceeds to ask, "What's the average amount for each segment?" LOKI provides a text summary along with the visualization showing the top 5 segments by amount. The user wants to see only the backlog opportunity type and simply types "only backlog" as part of the conversational flow. And LOKI responds with an updated summary and visualization. The user then wants to filter to the APAC region. LOKI responds by showing 2 segments that meet that criteria. Now, the user wants to see the filters applied to the analytical conversation and says, "Show me the filters." LOKI displays the current filters in play, and the user decides to save this query as a concept that they can use for later. The user types "save these segments as APAC concept." LOKI saves this custom concept in the database. The user can recall the concept and then use it in a subsequent utterance. "What's the average amount of the APAC concept?" LOKI responds with a single number displaying the amount. The user can continue applying filters to this concept by typing "only services." Now the user wants to know more about the other dataset, online activity. LOKI responds with the information about its attributes. The user wants to save the sales account IDs as a reusable concept by typing, "Remember these sales account IDs as service IDs." LOKI responds by saving the concept. Finally, the user publishes the concept so it can be used in other analytical tools such as Tableau by typing "publish service IDs." Now let's see how a published concept from LOKI can be used in other analytical tools such as Tableau. Here is a Tableau workbook using a reusable concept called APAC concept that was created in LOKI. A user creates a line chart showing the sum of amount over the close date with opportunity type encoded on color. APAC concept is used as a filter to include all the data values that satisfy the filter specified by the concept, and the line chart is updated. Let's now go over the system overview. In the LOKI system, a natural language understanding module based on the Rasa open source chatbot library accepts natural language queries from Slack. LOKI supports both informational and analytical utterances. Informational utterances allow the user to understand the data that is available. An utterance, such as "what data is available," responds with a list of data sources that were configured during training, and "tell me about sales" responds with metadata about the data source named sales, listing out the names of available attributes that can be used in the queries. LOKI also displays the data source's metadata in the event that is unable to interpret the user's utterance. The user interacts with LOKI by typing an input utterance, as shown here. The parser is trained on a set of analytical inquiries using templates of crowdsourced analytical utterances. As part of training, a set of data sources are specified over which LOKI operates. Sample utterances and entities are dynamically generated as input to the training using the templates as a guide. The parser module handles imprecisions such as misspellings and incomplete input by applying fuzzy matching and lemmatization on the tokens of the utterances with attributes in the data sources. The intents and data entities extracted from the utterance are passed to an action server. The action server runs analytical queries against a set of configured data sources to return a set of analytical intents and extracted entities. In LOKI, actions represent the analytical operations that can satisfy a user's intent. Each action is realized with a corresponding function that parameterizes the recognized entities from the natural language utterances and the current conversational state of the system. The actions then trigger queries to the data sources for retrieving the responses. A user can create a reusable concept from the result by saving the underlying data as a named concept, or by querying the result and saving the resulting data as a named concept. An utterance, let's call the segment C1, would save the data in the segment attribute as a concept C1. These concepts can subsequently be used in analytical utterances and in other related data sources with shared attributes. For example, what is the average amount for C1 would return the average of the attribute amount for those records that match the concept C1. LOKI can also persist these concepts back to the data sources for use by other systems such as Tableau. The intents and entities are finally used to generate visualizations and text responses that are shown to the user in Slack. We conducted a preliminary user study of LOKI to collect feedback on how people express and save user-defined concepts and identify system limitations and opportunities for how reusable concepts can be used to further data exploration. We recruited 12 volunteers, 6 male and 6 female. The participants had a variety of backgrounds ranging from user researcher, sales consultant, engineer, product manager, etc. Based on self-reporting by the participants, all of them were fluent in English and regularly used some form of a natural language interface such as Google. 7 of the participants regularly used a visualization tool and the rest had limited proficiency. Participants could interact with 2 data sets, sales opportunities with attributes describing product sales, and online activity with attributes describing activity in an online service. We began with a short introduction of how to use LOKI and the types of intents it recognizes. Participants were instructed to phrase their queries in whatever way that felt more natural to them. We discussed reactions to system behavior throughout the session and concluded with an interview. Each session took approximately 45 minutes. Overall, participants were positive about the premise of saving and reusing custom concepts in their analytical workflows. They appreciated the convenience of being able to save complex queries that involve grouping, aggregation, and filter expressions as named concepts. Future work should explore the ability for constructing concept maps of hierarchies, repairing and refining these concepts for more flexibility, and finally, recommending concepts that users may find handy during their analytical workflows. With that, here's the QR code to the paper and my contact details. Thanks for listening.